Assalamualaikum and hi, my name is Nurah Bizamiti Basruddin. So today I'm going to show you my development progress for my final year project. So basically my final year project is about festive season food recognition and also the calorie detection system. So before I write the code for this project, I need to prepare for the dataset. So my dataset consists of the training dataset and also the testing dataset. So for the training dataset, I have decided to use about 360 images, which is about 70%. And for the testing dataset is about 80 images, and it is about 22%. So all these dataset are retrieved from the Google Images. This dataset is actually consists of the 5 categories of the Hari Raya treat, which commonly consumed by the Malaysian. So the example of the treats are Emelandan, Bahulu, Ketupat Padas, Lemang, and also Tart Nenas. So this is my training dataset. So before I can process my dataset, I need to actually do some scaling, which means that I have to rotate my dataset. I need to scaling my dataset into the clockwise and also the anti-clockwise. So all the images are rotated for four type of degrees, which is 10 degrees, 20 degrees, 45 degrees, and lastly is 90 degrees. So as you can see right here, all the images is rotated according to the degree. So the images are also is resized using the image mesh processors. So the size of the images is 227 times 227 dimensions. So why I need to resize all the images? So this resizing is required in order to speed up the performance of the process for the recognition. So this is the training source code. So this line is where the data set are retrieved, and then it will go through the dataset one by one and read all the images and go through some of the process for the segmentation, and then it will extract the color of the images. So basically the images is need to be in the JPG format in order for it to extract the RGB value for the every images, and then the value of the RGB will be trained. After the training, it will proceed with the classify in order to classify it into 5 categories. So you can see right here. So this classification process is done by using the multi-SVM. So this classifier will actually predict the category of the images. So the result of the classification will be saved into the model. So I'm going to show you the training accuracy for my project. So it's actually going to take for a while. So as you can see, the training accuracy percentage is about 78%. And for the testing, this is the source code. So for this part, it will retrieve the dataset from the testing folder in form of GPG format, and then it will go through same process as the training. So the difference between the training and the testing is just the testing dataset use the different images, and it can't and the same image it doesn't use the same image like the training. So I'm going to run the testing. The testing accuracy is about 69%. So in case you are wondering, so I already asked my supervisor about the accuracy, and she said it's fine since the method that I use for this recognition is the new one and never been discovered before. So if the accuracy above 60%, and it should be fine. Next is the processing graphic user interface. So this is the source code. So let me run the source code. So this is where you can see how the recognition process is made. So right here, I want to try out the one of the images for the testing. So I chose the images. As you can see, this is the original RGB image, and I can turn it into the segmentation by clicking on the push button. And as you can see, it's actually extract the images, and it only focus on the food instead of their background, so it will get unselected. And then it also can extract the feature. So as I mentioned before that my project is focused on the color extraction. So the color is extracted from the images in form of the RGB, red, green, and also blue. So right here is the value for every color, and this RGB is important to differentiate the categories of the food. So after the color extraction is made, then it will classify what is the name of the food. And here is the reset button, so you can open another image. The next is the source code for the graphic user interface. Just use the same source code like testing, training, and also the processing. However, the difference between those three source code is the if else process. So it will actually display the calorie of the recognized food. So as you can see right here. Now I'm going to run the graphic user interface. So this is the GUI. So it's actually user actually can add the item, and then so let's try wine food. it will display the name of the food and also the calorie for pieces. And then if the user want to add another food, they can just click back on the push button, and the newest item will be added. So you can see right here, but this graphic user interface is not finished yet, and it still have some bugs that I need to fix. So it's supposed to calculate the grand total of the calorie value, and also it will like the user also can choose the number of the pieces for the food, and then it will calculate the total of the calorie, and user also can delete uh, the food item. So it's supposed to have a checkbox on this side, and it's not done yet. So the progress for my FYP right now is about 75 until 80%, I guess. Yeah. So I think that's all from me. Thank you.